Good day, students. Welcome to our lesson for this week. In this session, we are going to discuss integration by substitution on patterned algebra expressions resulting to inverse trigonometric functions. Before we start, let me present the formulas needed in this lesson. First, we have the integral of du over square root of a squared minus u squared equals arc sine u over a plus c. Next is the integral of du over a squared plus u squared equals 1 over a arc tangent u over a plus c. Then we have the integral of du over u times square root of u squared minus a squared equals 1 over a arc secant the absolute value of u over a plus c. First, let's have this example. Number 1, the integral of dx over square root of 16 minus x squared. So as you can see, our given is in the pattern of the integral of du over square root of a squared minus u squared, and its integral will be in the pattern of arc sine u over a plus c. So the first thing to do is to determine u squared. In this case, our u squared is equal to x squared, so u is equal to x. Then determine the value of a after getting the derivative of u, of course. Du is equal to dx. Then a squared equals 16, so a is equal to 4. So we will follow the principal root theorem because mathematically the square root of 16 is positive or negative 4, but by principal root theorem we will be using the positive root. Okay, so our answer will be arc sine x over 4 plus c. Number 2, the integral of 20x cubed dx over square root of 36 minus 25x raised to 8. So again, our given is in the pattern of the integral of du over square root of a squared minus u squared, and its integral will be arc sine u over a plus c. U squared is equal to 25x to the 8. So u is equal to 5x to the 4. And du is 20x cubed dx. A squared is equal to 36, so a is equal to 6. So as you can see, there is already 20x cubed dx in our given, so we will not change anything on du. So our answer will be simply arc sine 5x to the 4th power over 6 plus c. For our third example, we have the integral of dx over 9 plus x squared. So our given is in the pattern of du over a squared plus u squared, and its integral will be equal to 1 over a arc tangent u over a plus c. Our u squared is x squared, so our u is equal to x, and du is equal to dx. A squared is equal to 9, so a is equals to or is equal to 3. So our answer will be 1/3 arc tangent x over 3 plus c. For the fourth example, we have the integral of 10x to the 4th power dx over 9 plus 4x raised to 10. So again, our given is the pattern of du over a squared plus u squared. So the integral will be 1 over a arc tangent u over a plus c. U squared is equal to 4x raised to 10. So u is equal to 2x raised to 5. And du is equal to 10x to the 4th dx. A squared is equal to 9. So a is equal to 3. Our answer will be 1/3 arc tangent 2x to the 5th over 3 plus c. For our fifth example, we have the integral of dx over x times square root of x squared minus 81. So this example is in the pattern of the integral of du over u times square root of u squared minus a squared. And its integral will be 1 over a arc secant absolute value of u over a plus c. So our u squared is equal to x squared. So u is equal to x and du is equal to dx. A squared is equal to 81. So a is equal to 9. So our answer will be 1 over 9 arc secant absolute value of x over 9 plus c. For example number 6, let's have the integral of negative 2 cosecant squared 2x dx over cotangent 2x times the square root of cotangent squared 2x minus 25. So again, our given is in the pattern of du over u times square root of u squared minus a squared. So its integral will be 1 over a arc secant absolute value of u over a plus c. So based from our given, our u squared is equal to cotangent squared 2x. So u is equal to cotangent 2x. Getting its derivative, du is equal to negative 2 cosecant squared 2x dx. Okay. Our a squared is 25, so a equals 5. So our answer will be 1/5 arc secant absolute value of cotangent 2x over 5 plus c. Okay, so take note that our u can be a logarithmic function, a trigonometric function, or any other algebra expression. For number 7, let's have this. The integral of 28x dx over square root of 121 minus 49x raised to 4. So it is different from our previous examples. Here, you're going to determine what is the pattern. Okay? So obviously, our u squared is equal to 49x to the fourth power. So u is equal to 7x squared. And getting du, we'll have du equals 14x dx. But in our given, we have 28x dx. So you know what to do. We're going to multiply this both sides by 2. So we're going to have 2 du equals 28x dx. So obviously, our a squared is equal to 121 and a is equal to 11. Our given is in the form of 2 times the integral of du over square root of a squared minus u squared. So we have 2 here because of 2 du. Okay? So our integral will be in the form of 2 arc sine u over a plus c. Substituting the values of u and a, we're going to have 2 arc sine 7x squared over 11 plus c. So this is our answer. For number 8, we have the integral of 5x squared dx over 169 plus 25x to the 6. So if you don't know what is the pattern, so just determine the u squared first. So in this case, u squared is equal to 25x to the 6, u is equal to 5x cubed, and our du is equal to 15x squared dx. But in our given, we have 5x squared dx. So again, I know you know what to do. We're going to divide both sides by 3 or multiply both sides by 1/3. So we're going to have 1/3 du equals 5x squared dx. Now we have 5x squared dx, same with the given. So our a squared is equal to 169 and a is equal to 13. Our given is in the form of 1/3 the integral of du over a squared plus u squared. So we have that 1/3 du because of this. Okay? So our integral will be in the pattern of 1/3 times 1 over a arc tangent u over a plus c. Substituting the values of u and a, we're going to have 1/3 times 1 over 13 arctangent 5x cubed over 13 plus c. So multiplying 1/3 and 1 over 13, we're going to have 1 over 39. So our answer will be 1 over 39 arctangent 5x cubed over 13 plus c. Okay, so since this is more simplified, let's just choose this as our final answer. For example number 9, we have the integral of 4 dx over x times square root of 16x raised to 8 minus 9. So this given is quite challenging because yes, we can determine u squared. It is equal to 16x to the 8. U is equal to 4x to the 4th. But we have this pattern. This integral of du over u times u square root of u square minus a square. But obviously, our given is not in that pattern, okay? Because our u is 4x to the 4th. So outside the radical symbol, there should be u. But we only have x here, not 4x to the 4th. So obviously, our given is not yet following the pattern, okay? So we cannot directly substitute the values of u and a. So try to get du first. So our du will be equal to 16x cubed. Okay? So it is expected for us in our numerator to have 16x cubed. So we're going to multiply for x cubed. But the numerator and the denominator must be the same so that it is equal to 1. So it is just like multiplying our given to 1. So algebraically, it will change, but the value will still be the same when simplified. Okay? So multiplying that, we're going to have the integral of 16x cubed dx over 4x to the 4th times square root of 16 x raised to 8 minus 9. So now, as you can see, our given is already following the pattern of integral of du over u times square root of u square minus a square. Okay? So our du is 16x cubed dx. So since it is already the same with our given, so we're not going to change anything about it. So we will continue. But first, determine the value of a. A squared is equal to 9, so a is equal to 3. Now, substitute the values of u and a. Our answer will be 1/3 arcsecond, absolute value of 4x to the 4 over 3 plus c. Okay? So I hope you learned something today. Thank you very much for listening. Do not forget to like and subscribe so you will always be updated with our newest video lesson. So stay safe. God bless everyone.